Let's continue our session on linear motion. Yeah, we want to understand the motion graphs. So graphs of motion, they're one of the common things that we actually, like high school, right? We actually explore. So it's one area that is very critical that for us to know about linear motion. Everything we are going to talk about in this session, as we started so far, is going to be about linear stuff. So when I say velocity, your mind should be like we are talking about linear velocity. We explain all that because there's something like rotational velocity, there's something like circular stuff, right? Okay. But this session, whenever I just say displacement, I just say velocity, keep in mind that I'm referring to the linear ones. So everything is going to be on linear path. Okay. So let's wrap up. Let's catch up with some of stuff, right? So we talk about when you come to linear motion, there are some common things that we have like displacement, right? So we have displacement. The other one is velocity. Yes, velocity, velocity. Then the third one is acceleration. Acceleration is the third one. So displacement is just what it is, like distance in a specific direction. We spoke about that. Okay, but then, and this is measured in meters and everything. Okay, let's use a symbol for them. Let me, displacement, let me use S. Velocity, let me use V. And then acceleration, I'm going to use A, small letters, right? Uh-huh. So if this value, like displacement varies with time, if displacement varies with time, changes with time, we are going to get velocity. If velocity changes with time, we are going to get acceleration. Again, if displacement varies, changes with time, we are going to have velocity. If velocity changes with time, we are going to have acceleration. So there's that linear relationship where you have move from speed, velocity, or displacement, which is S, to velocity. Then if it changes with time, then we are going to acceleration. These things are changing with time. So if displacement changes with time, we have velocity. If velocity changes with time, we get to acceleration. As simple as that. So you see, these things are going to be varying with time. Time will be the thing that will be the factor, common factor for all of them. So displacement will be changing as time is passing by. Velocity is going to be changing as time is going by, and acceleration will also be changing as well. For this, right, each of them has a graph. For each of them, for displacement, we have a graph of displacement against time. We have a graph of velocity against time. We have a graph of acceleration against time, right? But because the acceleration doesn't give us anything, there's no third arrow. There is no third arrow, right? We are going to focus on these two main ones. So the two main graph that we're talking about is uh, displacement against time. For the time, I'm going to this T, right? For velocity, you go to velocity against what? Time. These are the two main graphs that we're exploring in this session for our level. So it's going to be displacement against time graph and then velocity against time graph. So we're calling this one, the first one, we call it displacement time graph and velocity time graph. Displacement time graph and velocity time graph. That's the common thing that we'll be using for each of them. So yeah, that's what we get. So we have established that we are going to focus on displacement and velocity time graph in these sessions. Okay, now let's focus on the first one. Let's do velocity time graph. So it's a when I say a graph, we're just basically talking about this, right? We have this, and I'm going to talk about this as well. Yeah, so we have the velocity time graph, and we have this. So this is the velocity will be here, and time will be here. So I'll do slash seconds. This one I'll do slash um, meters per second. That's velocity. Right? Meters per second. Let me write it to all. Let me write it to all. Let me write this to all. So this one will be velocity. It will be meters per second. Right? I'm doing slash the units. I'm doing slash the unit. That's what I'm just doing. Okay. Then the origin. We all know the origin. The origin will be what? Zero. The origin will be zero. So now let's see how velocity time graph work. So we graph that we see. So anything aside this as this line is going to be there. So there will be time here. Let's say 1, 2 seconds, 3 seconds, 4 seconds doing. These guys also they also have levels, right? 1 meters per second, 2 meters per second, 3 meters per second. It's a graph. So the stats, right? We are going to start from zero. Let's say the body, the car is at at the beginning is at 0. So we will be moving it like this. The body will start some motions, go like this, right? Then go like this, come like this. So this is an example of velocity time graph, right? So we are doing velocity against time. We are not going to go deep into it. We're just going to basically introduce ourselves to some of the things. Then we'll do a lot of calculations on them as time goes on. Okay. So now, whenever we are doing velocity time graph, right, there are two things that we need to keep in mind. The thing that we'll be looking at will be the slope and then the area under the graph. Slope and area under the graph. These two are very important when we come to velocity time graph or like graph motions, right? Linear graph, linear motion graphs. So okay, so we are going to focus on slope, area. Slope and area are two very critical things that we are going to talk about. What do you mean by the slope? What do you mean by the slope? Let me do this. Let me change the color of my pen. Yeah. So I'm doing this straight line. So this straight line, we say, is a moving straight line, and then it's not missing anything, right? This particular thing is not moving up, down, up, down. This is just a straight line. But the moment we change it from the horizontal position to something else, like use another color. Let me use another color. Let's say it will move from here to here. Then, okay, before that, let me clean this thing for you. Wait to myself. Remember, everything is still in linear motion. So we move there, right? So we see that the body was straight first, and then move up, then go back to straight. Let me do for straight. Let me use another color, right? So they move. We are now straight. So you can see that at this level where the thing move, right? The thing move from. Let me use my original black. So when the thing move from here to here, this level, you see this side, the thing move from here to here. There's like an increase. There's an increase, right? It's no more straight line. It's not more straight horizontal like this. Like it has moved from a down level to an up level, but not like it didn't move like this, but it moved curve in a way at a particular angle, right? Up. So these sides we call them slope. Then so we can be able to measure slope over here. So for this particular graph that we drew originally, we should be able to get some slope. So the slope that we can get there's a slope here, there's a slope here, and there's also a slope here. It doesn't necessarily have to go up. So once it's not horizontal, the thing is not horizontal, it's not a slope. So these areas are areas of slope, right? So most of the graphs that will be having slopes. So when they put them to here at the beginning, there's a slope from the start, then there's a horizontal line, then there's another slope, the horizontal line, and then there's another slope, but this slope is downward, right? So basically, this is how we be meeting most of the graphs, which will be having the slope attached to them. Okay, let's look at another concept, right? That's about slope. So you should be able to identify slopes for graphs. Okay, so this particular graph has three slopes. And then the other one that we're talking about is the area under the graph. So let's say we have this for now. The area under the graph is the entire how do you call it, surface that it covers with between the graph and then the horizontal line, like the t-axis. So sometimes you can call it the x-axis, right? This total area. So I'm going to cover it like this. So this total area. So this is the line, and then I'm covering it like this. So this particular side, this particular area is the area under the graph. We call this the area under the graph, right? So there are two things that we talk about: the area under the graph. So the area under the graph is to get the line of the curve, right? And the horizontal line or the x-axis. And that x-axis, make sure that we are focusing on the total area that it covers. We are not shading this side because this graph doesn't extend to this side. It's not that. It's just between the graph and then the t-axis. That will be the area of the graph. Okay. So now keep in mind to find the area under the graph, right? There are some questions that we ask that, okay, for a velocity time graph, what does the area under the graph represent? For what does the slope also represent, right? So let me quickly take you through that. So we are talking about velocity time graph, right? We're talking about velocity time graph. Velocity time graph is like this, right? Velocity and time. So for the slope is equal to whatever I have in y, change in y. So this is usually on general axis, this is y, this is x. Let me clean the t and b for now. So on every axis, right? On every graph of axis with two dimensions, slope is equal to the change in y over the change in x. That is generally for every graph. But for this our graph that we are examining, instead of calling them x and y, they are calling them p and what t. So our slope for this velocity time graph will be something like change in v over change in t, because right now we are not having y, x, right? We just change the name, just change of the name, we have to find it. So change in velocity with time. When a velocity changes with time, what did you say you have? You are going to have what? Acceleration. So for a velocity time graph, the slope is actually an acceleration. For a velocity time graph, the slope of the graph is actually an acceleration. And this is how to get that. Now, what about displacement distance under it? For the distance, what you do is you do for the distance, what you for the area under the graph, for the area under the graph, what you do is that you need to multiply y times x. This is what you have to do for the area under the graph. So because we generally assume that if we have a rectangle, right? We have a rectangle. Let's say we have a straight line like this, right? So we want to cover this. The area under this will be this area. So there'll be a particular v point over here, and there'll be a particular t point over here. So this is a rectangle, right? For rectangle, we have length times what? The width. So now the area of a rectangle is what? Length times width, right? So the area is equal to L times W, right? So basically, that's what we are doing to get the area under the graph. So if you find the area under the graph, it's basically multiplying the V, the Y component, and the Z component to get the area under the particular graph. So in this case, we are dealing with, we are not dealing with Y and X, but we are dealing with what? V times what? T. Velocity time is time. So this one, what particular parameter will it give us? You need to also keep in mind that we say velocity is equal to what? Displacement s over time, right? This is the formula for velocity. The formula for velocity for what we have discussed so far, right? So now if I'm doing cross multiplication, this two multiply this will give me v times t is equal to s. So you can see that this v times t is equal to s. This is what we are having here. So, and then we say v times t is area under the graph. So actually the area under the graph for a velocity time graph is actually the displacement or the total distance covered, right? So for a velocity time graph, the area under the graph is what? The area under the graph is basically how do you call it? The total displacement covered. And this is the velocity time graph. I can use another example for the other ones. That's the next one will be displacement time graph, right? Displacement time graph. So I'm going to talk about some displacement, say like this, right? If you have something like this, there's one slope here. So slope will be equal to what? Change in s over change in time. So s over t, right? And then the distance under the graph will be s times t. That will be the displacement under the area under the graph. And then s over t will be what? The slope for each slope. That's what you keep in mind all the time, right? Yeah. So so now we know slope and then velocity under the graph, and then we know what each of them represent for the various graphs. So in the next session, let's actually use this and do some simple calculation on velocity time graph.